So first of all, I'll introduce myself. Hi, I'm Steve Lene. I'm one of the application engineering managers here at SimScale, and Darren's going to be presenting today. He's going to be the star of the show for this hands-on workshop. Darren's experienced in CFD and engineering design, and he studied aerospace engineering at Brunel University, and he's a valued member of our application engineering team here at SimScale. So first of all, I'll introduce things to you very briefly. Who are we and what do we do? Well, we're SimScale, and we created the world's first cloud-based engineering simulation platform. And on this platform, you can do fluid dynamics, CFD, solid mechanics, FEA, and thermodynamics. And as you're going to see in this hands-on session, everything is accessible through a web browser. So how do you get the most out of this workshop? Well, what we're going to do is allow you to follow along with Darren. And there'll be milestones in the project to make sure that you stay on track and you follow along. So at the end of each milestone, all you need to do is open the next milestone on the left-hand pane, and Darren will show you how to do this. Please feel free to ask questions as we go through. I will be manning the questions, and if it's something that just needs to be addressed with the person who's asked it, I may send a question answer back to you in GoToWebinar, or I may stop Darren and get an answer to the whole audience. So please feel free to use the questions functionality, and we'll address them as we go through. At the end of this session, the great thing is you'll have a working simulation setup that you can always come back to and use again. Okay, so that's all from me. I'm going to hand over to Darren now, and he's going to take you through the setup. Thanks.
Thanks very much, Steve. Cheers. So let me just reintroduce you to the case that we're actually going to be setting up. I did cover these slides very briefly in the end of the main webinar last week, but let me just go over them again just to give you some context as to what we're going to be doing today. So firstly, what we're actually looking at is a very small traditional OpenRL data center. The idea of this is to get you used to the workflow of setting up one of these cases. And then, of course, you can take this setup to apply to any of your scenarios or setups. So this simple design has underfloor cold air supply. It's got 16 42U server racks and 2 chiller units aligned with the hot aisles. And cold air is actually supplied at 20 degrees Celsius. And what we're actually interested in finding out is the temperature distribution and also the flow pattern within this space to identify where this design could be improved, understand how some servers may or may not be hotter than others, and really to analyze these results to make design decisions. So that's the goal. But what we're going to be focusing on, of course, is how to actually get there. So today's agenda, we will briefly cover various few steps. And actually, if I move to the next slide, this gives you a much better breakdown of what we're actually covering. So we're going to start in a labeled environment. So there is 10 main milestones. I will start at the starting point. And we'll work our way through each of these points together. So at no point will I be doing something different to what you're doing. Okay, so we should be able to cooperatively go through this list, check things off the list, and actually at the end obtain a simulation run and analyze those results. So I'm not going to spend any longer on the slide deck at all. What I'm going to do is I'm going to hop over to the simulation SimScale platform. And what I'm going to do is I'm just going to drop this link into the chat, okay? So Steve's going to be posting a link into the chat function. So as soon as you follow that link, what should happen is you'll be brought to the same screen that I'm in. And what we're actually going to do is we're going to copy this project. And the reason we're going to copy this project is so that we all have our own copies of the project so that we can follow along. So I think maybe what's best to do is, as everybody gets to this stage, maybe just pop your hands up to say that, yeah, you're at this stage. and then we can start moving on from there. And of course, if you've got any questions or if something's not quite working right at this stage, now is a good time to type a question, because ultimately, if we've got a problem now, then we're going to have difficulties later on. So best to let us know if you've got any issues right now. Hopefully, if you've managed to get your SimScale account all up and running properly, then we should be at this stage together. Okay, so I'm going to move on. I can't see any hands up or any questions or anything, so I'm going to move on. What we're going to do first is copy this project. So we're presented with this screen, and this is my original project. And what I'm going to do, just like what all of you are going to do, is copy this project. So that is this little icon here. So copy project. And what we're actually going to do is we're going to give this a sensible name. So I'd say put your name next to the data center. So data center dash, and my name is Darren Lynch. And we can, I think you have the option to keep it public. So let's make it public. And if I wanted to, I could add some sort of description here, but we're just going to copy this project. Okay, it looks like we've got to actually type something here. So just type data center webinar example, and that should suffice for now. There we go. So this is now going to copy to our dashboard. And if we're successful, we will end up in the SimScale dashboard with this environment where we can actually see all of our geometries and all of the milestones that I discussed before. Now, what we're going to do is we're going to start, as I said, at the starting point. We're going to prepare this geometry ready for CFD simulation. Okay. And as we complete each and every stage, we're going to move on to the next milestone. And the idea of this is so that we're always at the same stage. So it doesn't matter if you don't exactly follow at a certain stage. What you can actually do is just catch up with us by moving on to the milestone that I tell you that we're on. So I hope everybody's good to now. If anybody is perhaps not here or has any troubles, maybe just pop your hand up, ask a question, and Steve can actually help you out. Okay, good. So the first thing we're going to do is we're going to go to starting point, which is a very natural beginning to our journey. And what we can see is we've got a geometry that we've just uploaded from a CAD software up to the SimScale platform. And what we actually require in SimScale is some sort of volume representation that allows us to simulate just the air. So we want to have a volume or an enclosure that represents this air around the enclosures, around the server racks. So what we're going to do is we're going to do this all within the SimScale platform. So I'm going to come up to starting point. There's 3 little lines that give us more options. And what we're going to do is we're going to go to edit in Cad mode. Now this is in beta version, but it's already very capable of actually dealing with geometries. And I'm going to click on this, and it's going to take me to a different environment altogether. So I've clicked on this, and it's taken me to this CAD preparation environment. Now, what we actually want to do is, as I mentioned before, we want to create a volume enclosure. So this represents the room or the space within the room that is actually occupied by air. So to do this, I'm going to come to flow volume. And the flow volume that I actually want to create is called an external flow volume. And when I click on that, it creates this, this representation of what I'm going to create. Now, obviously, this isn't what we want to be simulating. So it's up to us to actually put some definitions in here to create that volume. So I'm going to go nice and slowly here, hopefully giving you time to copy down the same numbers that I'm inputting. And whilst I'm doing that, I will read them out to you if you can't see more than one screen at a time. So for the external flow volume, for the minimum point, what I'm going to put into the X direction is minus 2.65 meters. Okay, minus 2.65 meters. In the Y point,
Sorry,
Of course,
Darren, can I just interrupt for a moment? We've had someone just message in to say they can't follow the speed of the presenter. So at this stage, would you mind just slowing down a little bit, and hopefully that will help?
Absolutely, no problem. Okay, yeah, no problem. Hopefully we're here. Do you want me to repeat the step going into the CAD environment, Steve? We'll be okay.
Yeah, maybe just show that step again, getting into this CAD window.
Absolutely, yeah, no problem. So we're again going to return to the SimScale platform. So I'm going to actually press cancel on this operation. This is the SimScale environment. Obviously, what we actually want to do is locate the geometry that we're going to start from. So that's located on the left-hand side under these geometry sections. Okay. Now, maybe if we're struggling to follow along, maybe I'll give a little bit of an introduction as to the user interface of the SimScale platform. So in this main space, this is what we call the viewer. This is where we actually graphically manipulate everything so that we can interact with the model, assign certain things. We can also select things as well to hide and show, for example. And on the left-hand side, this is what we call the simulation tree. And this is where we're going to be spending most of our time. So if I want to do a geometry operation, it's in this space that I'm going to be performing it. If I want to do something to the simulation, it's in this space that I'm going to be performing it. And hopefully you can see my cursor here as well. Okay. So to get into the CAD environment from the starting point, what we're actually going to do is click the three little buttons and edit in Cad mode. Okay. So this is where we're going to enter this new environment. So I'm going to go ahead and click that, enter Cad mode. Good. So hopefully we're all at this stage. So we're in this environment and we're ready to actually create some volume enclosure. So this is what we want to actually do the simulation based upon. Okay. Now to do that, we've got to do some sort of operation to create this space, and that is located on the top here in this panel from the drop down of flow volume. And I actually want to be creating an external flow volume. That means there is a volume surrounding my main parts of interest. Okay. So I create this external flow volume. I click it, and it creates this this space. Now this space has got to actually be representing the room that we're simulating. So at the moment it's much too big. So we've got to input some values to bring it into the right size in the right place. Okay, and that's what the minimum and maximum points are going to control. So I'm going to put the minimum point, so that is one corner of the room, and the maximum point is going to be the opposite corner of the room. Now I've got these values written down, so this is what I'm going to be inputting into this panel. Okay, and as I said before, I'm going to read those out. Hopefully you can easily follow me as I'm speaking it and typing it, but I am going to spend a little time and let you see the values that I'm inputting as well. Okay, so on the X position of the minimum point, I'm going to type in minus 2.65. And in the Y, I'm going to type in minus 3. Okay, so you can see here, we've actually brought this enclosure back down to this first point, and you can see that I've entered this point as the first point. Okay, so this point here resides at minus 2.65, minus 3, and minus 0.1. So my next job is to actually bring the second point, so that's this point up here, to the opposite corner of that room. And we can do that by entering the values 7.95, 3, and 2.5 meters. Okay, and you can actually see that now we're actually getting a better representation of this room that we've created. Okay, now what I'm going to do is next move on to the next step. So that is actually to pick a seed face. Okay, now a seed face essentially helps this understand what part of the room we want to actually analyze. And I'm going to simply click the top of this, this chiller here. So it's a face selection. I'm going to graphically select it in the viewer, this central viewpoint. And I'm going to select this face here. So that highlights in blue straight there. Okay, good. And finally, what I want to do is there are some parts that need to be excluded from this volume extraction. So the operation that this automates is actually where we would create a box and we would take all of the parts that are within this space away from this fluid volume. But we've actually got things in here that we want to keep for the simulation later. Now that includes, now let me just hide something. If I just hide this, this space here, we can actually see that within each of these enclosures, we've actually got an orange part, which represents every single server rack, and also two green parts, which represents the doors on either side. And it's these that we want to actually keep for later. And when we say we want to keep for later, we want to select all of these parts in the excluded part. Okay. Now, this is quite a few parts. There is, I'm going to tell you, there's hundreds of parts here to exclude. So we're obviously not going to go and select these individually. Instead, what we're going to do is we're going to start by hiding the parts that we don't need to exclude. Okay, so a little bit of logic there that helps us through this workflow. Okay. So I'm going to select. Okay, so what for now we can select into this excluded parts area, and this area should become pink. Okay, very key there. It should become pink. And what we're going to do is we're then going to navigate to this little toggle that says, actually, for now, I don't really want to add anything here. I'm just going to toggle this to pause the assignment. Okay. And by pausing this, this allows me to actually make selections in the space without assigning it. That is essentially what this means. Now, what I want to do is I want to go through and select all of the server enclosures. So that's all these black bits. So I click every single one of these black bits and I hide that. Okay, I hide that selection, which is quite handy because then we get exposed all of these orange parts, all of these green parts from within the server. Now, what I'm also going to do is I'm going to select this floor of both areas, and I'm going to right click and hide those as well. Okay, good. So now what is left in our viewer? This little pale blue box, but also all of our server components and our floor panels that are going to be breathing air into the domain. And I'm going to click that toggle back on, so we can now make a selection. So everything we select here is going to be part of this assignment. I'm going to tick it back on. I'm going to right click and I'm going to assign all. Okay, there we go. So now everything becomes pink. There we go. Now from here, we've actually got a fully defined operation. Okay, so we know what our maximum and minimum points are. We know what our seed face is. And we also know what we want to exclude from this operation. And I'm going to go apply. Okay, so by applying this, this actually does this geometric operation. And this takes a couple of seconds to process, but it doesn't actually take very long in the grand scale of things. And what we get returned is going to be a volume representing this fluid domain that we're actually going to be simulating on. Now, hopefully everybody else's is a bit faster than mine. Okay, maybe Steve, I don't know if you're on the chat. Is everybody else successful with this operation?
Yeah, nobody's raised an issue yet. If anyone's struggling with this step, send a chat or a question. If you are having trouble, don't worry. You can just start from the next milestone.
Absolutely. Okay, thanks, Steve. Good. So hopefully, when the operation is finished processing, finished thinking about it, we actually get this nice blue volume that represents what we're actually going to be simulating in the next step. And just to show you what that looks like, if I open up, so I've selected 3 faces and I'm going to hide them just quickly, just to show you what that looks like. We can see inside this space is actually your servers that you're going to be simulating with all of the elements that we wanted to keep. So without further ado, I'm actually going to press finish, and you'll be glad to hear that this actually brings us to our first milestone. So once we finish this operation, we have successfully completed milestone 1, okay? Which means everyone can actually give themselves a massive pat on the back, but also move on to the milestone 1 geometry that I've provided here. So if everyone can click on this milestone 1 geometry prepared step, that would be grand. This brings us all to this same step. Hopefully now we are all at the same step where we can actually visualize this this object that we're going to be simulating in exactly the same stage. Okay, so on to working towards milestone 2 then is going to be creating a new simulation. Now, to do this, what I recommend doing is coming up to milestone 1, geometry prepared, and there's once again the additional options section, and we're going to navigate across to create a simulation. Okay, so that's going to create a new simulation, bring up the dialog to create this new simulation. So I'm going to click ahead here. And the one that we're actually interested in is the convective heat transfer analysis type. It should be pre-selected for you. And right here, we can go create a simulation. Okay, bottom left. Now, we could name it something sensible, but I'm not going to spend too long on these renamings because what we're going to be doing is sticking to the milestones I've predefined anyway. But what we do need to do here is one of 2 things, okay? Firstly, we actually need to turn on the turbulence model. So this is a turbulent flow. We're going to select K omega SST. That is our go-to turbulence model at SimScale. Okay, and that's available as soon as you've created this simulation. Before you navigate away from this panel, we've got a list of options, and one of those options is this turbulence model with a drop-down list. K omega SST is your selection there. Good. The other thing that we need to do is actually define what direction is up and what direction is down. And the way we do this is by defining gravity. Okay, so this helps with the solver actually understand what the buoyancy effects are going to be doing. So I'm going to come across to a tree item called model. Okay, and here we've got a lot of null values for gravity direction. What we actually want to say is if we look at this little cube on the bottom right, if Z is the up direction, gravity is acting in the negative Z direction. And because we're being asked to define this in meters per second squared, we're actually going to provide the value of gravity here on Earth, which is minus 9.81 meters per second squared, because we're acting in the negative Z direction. And once you've entered minus 9.81 for the Z component of gravity, so there's X, Y, and Z components, we can actually save that. Okay. So now we've created the basis for us to work upon. We've actually come to milestone 2. Okay, so we have completed milestone 1. We have now completed milestone 2. So what we're actually going to do is navigate to the tree item that says Milestone 2, just so that we're all on the same page. So click on Milestone 2, simulation created, which brings us to exactly the same thing that we've just seen, except we know that we're all at the same place. Okay. Now, when we're setting up one of these SimScale simulations, we're looking at this what we call the simulation tree on the left. And what we're rather after doing is looking at this as a checkbox type system. Okay, so what we're actually doing is we're going from the top to the bottom. Okay, and every time we see something that's red, we know that we need to define something here. Okay, we need to define something here. Actually, is more the case. So the first thing we actually need to do when coming down this list is define a material. Okay, and in our case, we're doing a fluid simulation. The material is actually going to be some kind of fluid. And of course, that fluid is going to be air. Okay. So to define that, what I'm going to do is I'm going to come down to materials, which is a little red circle with materials. I'm going to move across, and there's a little plus button that says create a material for us to use. And we automatically get taken to this material selection area. Now you can define custom materials, but for now we're just going to use air, the default values. And I'm going to press apply. Okay. Now handily is the first selection, so we don't have to actually select that. And we don't have to do anything else other than select this blue volume to the assignment. So what we're saying is the fluid volume or the fluid representation is air. In this case, okay, and it becomes a lighter shade of blue, representing that we've actually made that selection. So now what we've done is we've created a new material, we've assigned it to something saying that this is air, and that is what we're dealing with. Good. So that was quick. We're now actually at milestone 3. Okay. So we're going to go on to milestone 3 to make sure that we're all in the same place once again. And you can see that we're seeing the exact same thing. Okay, we have defined air as a material, and the next on the checklist is actually boundary conditions. Now, there are quite a few boundary conditions to actually assign here. Firstly, I'm going to concentrate just on the cooling system. Okay. So I'm going to close the air assignment. Now, what might help us here is if we change the view to transparency mode. So in the main viewer, so this main viewer here, from this render mode, so that's second from the left, we can do a drop down and view translucent surfaces. Okay, so that gives us a bit more visibility into this area. And what I'm going to do is I'm going to hide a few faces. To do this, we can actually select face selection. So on the top here, there is an item called face selection. It looks like a little face selected in red. And I'm going to select the 3 faces that is closest to me. Okay, and if I show you what that looks like in solid view, you can see these 3 faces are selected. Now I'm going to right click and I'm going to hide that selection. Okay, now this actually gives us very good visibility of what's going on inside, but also allows me to select things that's inside the fluid domain. Okay, so these 2 objects, let me just change the view a little bit. These 2 objects here, these cubes, these are our chillers. So air is actually being returned to these chillers through that top face, but it's being supplied to the room through these bottom faces, and that's what we're concentrating on here. So I'm going to go through those 2 boundary conditions. So the first boundary condition we're going to create is the return air. So that is these 2 top boundary conditions. So I'm going to go to boundary conditions on the left-hand side here. It's a little red circle. And I'm going to press plus. And I'm going to define that as a pressure outlet, okay? Which is actually a quite nice boundary condition because you don't have to define too much. And the selection I want to make is the tops of these cubes. So if I change that view mode again, this time I'm going to change it back to surfaces with wireframe so you can see me better. And you can also see yourselves what you're doing better. You can actually select those two top faces and they become a lighter shade of blue, designating, also showing you the fact that they've been selected. Okay. Now, to make this easily readable to you, I'm just going to quickly rename this to make this a bit more followable. I'm going to call that return air. There we go. Next up, what we're going to do is we're going to define the supply air. Now that is actually supplied at the bottom of the domain or the bottom of the room through each of these little patches. And I'm going to do something that may seem a little confusing, but hopefully not too confusing. I'm going to rotate this geometry so that I'm looking at the bottom of the geometry. So I can actually select faces on the bottom. And you can do that by clicking into the viewer space and then moving your cursor around. Okay, so then all of a sudden we become, we get the visibility of these floor patches. Okay. And I'm going to create a new boundary condition and call it supply air. And that is going to be a velocity inlet type. So the first boundary condition we come to is a velocity inlet. Now, you can see this one is a bit more complex or involved to actually set up in comparison to the pressure outlet. The first thing we need to do is, I recommend renaming it. So we're going to call this supply air. There we go. And then what I'm going to do is I'm going to change the velocity type. So that's the second option down. Velocity type to be flow rate. Okay. Now, once we've changed that to flow rate, we also get an additional two options. Now, I'm going to change the flow rate type to a volumetric flow rate because actually, for these kind of simulations, that is a more sensible thing to be dealing with. So here, I'm actually going to be using a flow rate value of 0.49 meters cubed per second. Okay, 0.49. And hopefully you've all had a chance to copy that down. That was 0.49 meters cubed per second. And the supply temperature is going to be 18 degrees Celsius. Now, what's left to actually do is assign this to some inlets, some faces to be used as inlets. Now, what you can actually see, that these panels coexist with the surfaces that we want to assign. So we're going to have to do a little bit of visibility change here. The first thing we're going to do is we're going to stop the assignments of faces. So I'm going to toggle this little button here. So stop that assignment. And what I'm going to do is I'm going to select a volume. So third option on the top of this view space is select volume. We're going to select this fluid domain, so the blue one. So if I just tick off it for a minute, the main fluid space is the blue one. And I'm going to right click and I'm going to have hide selection. Okay, so that has shown everything that is not what we want. Not to confuse you too much, it's hidden the one that we want, but we have got this useful tool. If we right click, we can invert the selection. Okay, so that speeds up the process of hiding all of these different volumes into just 2 clicks. Okay, so now we've hidden the fluid volume, we're going to invert that that visibility. Sorry, invert visibility. That returns our fluid volume with nothing else. And now it becomes much more simple because now we can just turn back on the assignment and select each of these faces in which we want to have this flow moving in at. Okay, so I'm going to tick each one of these little squares at the bottom of that geometry. Sorry, I have trouble clicking and talking at the same time, so I'm not breaking it up, I'm just clicking. Good, so once 16 faces has been assigned to this, this boundary condition, we can actually save that. And this signifies that we move on to milestone 4. So we have now correctly defined the all of the chiller related boundary conditions. And thankfully, the next two boundary conditions are going to be much easier. Okay, so what I'm going to do is collapse this milestone 3, and I'm going to expand milestone 4. So that's where we are at. We've successfully defined these 2 boundary conditions, and now we're going to define the other boundary conditions for the rest of the room. Okay. So what we're going to do now is we're going to create a new boundary condition using the same technique. We're going to have a little plus button. We're going to select, in this case, the wall boundary condition. Okay. So that we know what the context is, this is actually going to be the boundary condition assigned to the ceiling. So I'm going to call that appropriately ceiling. You don't have to rename yours, but it does help me follow along my own simulation setups. And I'm going to change the temperature to a fixed temperature of 20 degrees Celsius. And using the same clicking technique, I've just assigned the ceiling of that, that box. Okay, so you can see that now it's a little lighter color. Good. Next up, we need to define a boundary condition for the floor, and we do exactly the same thing. So we create a new boundary condition and we select wall. Okay. Now this is going to be floor, so I'm going to name it such. Floor, there we go. And the temperature that we're going to assign to that is 19 degrees Celsius. Okay, and we're going to click these bottom 2 faces as our assignment. So the floor of the room is our assignment, and that is 2 assignments. You can see there are 2 faces is the assignment, and that is now a lighter shade of blue. And that's that boundary condition finished with. And the final step of this, this milestone is to actually have the other 4 faces around the edges. So this face here, this face here, this face here, and this face here. We actually assume in this case that there are other instances of this part just mirrored around these planes. So we're actually going to say that these are symmetrical planes. But of course, you are free to modify this for your own needs, of course. And to do that, we're going to come up once again to boundary conditions, press the little plus button, and assign a symmetry plane. And what I actually did is I pre-selected those faces, so it was automatically assigned. But just so that you can see the workflow, I can remove all those assignments, and I can go around the room, essentially, go around the room, selecting these faces. There we go. 4 assignments, now a little lighter blue color. So that is all assigned there. And actually symmetry is quite an appropriate name, so I'm going to leave it at that. Nice. Okay, then we have completed milestone 4, and we move on to milestone 5. See, pattern forming. Now, milestone 5 is all about setting up the servers themselves. Okay, and hopefully we're all at the same stage where we have the fluid volume represented in blue, but nothing else. So what I want to do here is I want to right click, I want to invert visibility, and that shows me all of the things that we're going to be defining in the next couple of milestones. But in case someone wasn't able to do that, I will actually show you the workflow to get you back to this state. So I can actually right click on the viewer, and I'm more than happy for everyone to follow along to this. Click show all. There we go, show all. Everything is shown. Make sure that we're on volume selection. That's the third from the left on the top of this viewer space. And click click the fluid and hide it. Okay, and that's how we get back to all to be on one visibility stage. Okay, so let's crack on with this step. The section we're actually interested in is under what we call advanced concepts. So on the left-hand side here, there's a little node, and that's called advanced concepts, and I'm going to expand that. Okay. The first thing that I'm going to do is actually define the porous media. Now, porous media is actually a fancy way of saying there's a volume resistance. Okay, so if you imagine some sort of netting or perforated plate, this is what we're actually talking about here. So I'm going to come across to porous media under advanced concepts, and I'm going to press the little plus button, and we get a lot of options. Right at the bottom of these options is what we call the perforated plate. Okay, perforated plate is a very simple definition for these resistances. Actually, if we click it, all we have to do is define what flow volume, what flow direction this is being a resistance in, and also what the free area ratio is in. Now, for all of the selections that we're doing, we're going to keep the same free area ratio as 0.6 across the board to make it easy for you. Okay. And what we're going to do is we're going to first concentrate on the flow direction. So if we look at just the doors, so that is the green ones, the green volumes, we would expect a resistance to be only in the X direction. Okay, so that's along this panel. So therefore, the default flow direction is actually correct in this case. It is only in the X direction, 1, 0, 0. So we can leave it there. But we've actually got quite a lot of these volumes to actually assign, and I'm not going to make you go through and select all of them. What we're actually going to do is introduce a new tool, and that is the box selection. Okay, so on the top of this viewer space, we've got this activate box selection. And what we're going to do is we're going to do this, we're going to do it 8 times. Okay, so I'm going to go very, very slowly for this first time. We've got the box selection activated. I'm going to click just the top left hand side of this line of doors, and I'm going to put a box that encloses all of those doors, and I'm going to release my click. And you can see the assignment that's been created is 4 volumes, and if I rotate this view, you can actually see that those four doors have been assigned to this perforated plate. Now we want to do that for every single row. Okay, so 8 times, select, activate box selection, encapsulate that selection, release. Now we've got 8 volumes assigned, and we want to do that for every single row of doors. So do that in your own time. I'm going to go ahead and do that on the screen now. And as you can see, as I make these selections, 4 more volumes is assigned every single time into this space. Final rows. There we go. So we have now got all of these doors assigned to this perforated plate. Now I'm going to save that. That is fully defined now. So we've got 32 volumes assigned to that. Save it. Okay. I'm not going to rename this one. We could rename it. We could rename it doors. In fact, let's just do that. But then we want to move on to our next assignment, and that is these perforated plates at the floor. Okay. So once again, there are 16 of those, and we can use the same techniques that we just used, but with a little bit of a difference. So I'm going to orientate myself to the top-down view, come back to porous media, and create a new perforated plate. Okay. You can feel me speeding up here. So I'm going to rename these to perforated plates. So that is where the cold air is coming up from the floor. And we're going to change this once again to 0.6 free air ratio. Now, interestingly, because the flow is going to be going from bottom to top, the flow direction is actually in the Z direction. Therefore, the default direction is now no longer applicable. So I'm going to go in the X direction 0, in the Y direction 0, and in the Z direction 1. Okay, and you see this arrow representing the flow direction being reorientated. So looking from the top-down view, I'm going to use my box selection tool again, but this time I'm going to use it a bit differently. I'm going to make these selections from the bottom right to the top left. And instead of having a blue box, we've actually got a yellow box. And that means that anything that this box actually touches is going to be selected, not necessarily encloses. Okay. And I'm going to release the cursor. And once again, we get 4 assignments added to that selection. And I'm going to do that for each of these. I'm going to be a bit cheeky, and I'm going to do it. I'm going to do it for both of these rows of floor panels. There we go. And then for the one on the far left. And at the end of it, we should have 16 volume assignments. And graphically, you can see that everything that is assigned is blue, and that is the representation for each of these plates. Okay. So that actually, we're at milestone 6 now. So we've actually defined porous media. So I actually encourage you all to now move to milestone 6. Expand once again the advanced concept section, but this time we're going to be assigning something called power sources. So power sources, now this is quite a nice simple definition. Power sources are assigned to all the orange things. Okay, so that is representing an individual unit, a server unit within that rack. And we're going to come along to power sources, press the plus button, and assign it as an absolute power source. Okay. Now, using the tricks that we've just learned, we're going to activate the box selection, and we're going to actually operate that in the same way from bottom right to top left with a yellow selection box. And you can see that I've just covered the center of these orange boxes representing these heat sources. Okay. And 168 volumes right there on the first row. Now I'm going to replicate that for all 4 rows very quickly. There we go. At the end, we'll have some 700 volumes selected, actually. Specifically, 672 volumes. And I'm going to call this heat source. Now, something that obviously the most important part of this is actually to I clearly can't spell source today. We'll call it heat. The most important part of this is actually assigning this power source value. So this is going to be based upon every single selection that we've done. So emphasizing that the value that we put in here is going to be applied 672 times. So it's going to be a very low value. And actually in this case, it's 166.7 watts. 166.7 watts. 166.7 watts. There we go. And we can save that. Okay. And that is actually the end of that milestone. So we can move along to milestone 7 now. Okay. After applying this 166.7 watts value to our power source, we can once again come to milestone 7, back down to advanced concepts. And what we're going to be doing now is we've applied these flow resistances, we've applied the power, heating power that is being applied by these servers, but we have missed the air movement from these fans. So the each server is going to have its own fans to cool the server unit, and we've got to represent these somehow. And we do this by actually creating a momentum source. Now, little snippet of information: momentum sources are average velocities per volume assigned. And the actual workflow here is a little bit different because we are going to be using the box select tool, but we've actually got 2 different directions. Okay, so we assign a velocity in the positive x direction or the negative x direction. So depending on whether flow is going from left to right or right to left. Okay, so key difference there. So firstly, the speed of the flow is 0.3345 meters per second, or let's just say 0.3, just for argument's sake in this case. We'll say it's 0.3, but we want to decide whether it's going in the positive or the negative x direction. So if we look at this far right row, we create a selection, same way as we did before with this yellow box selection tool, bottom right, top left. 168 volumes assigned. Now, the cold air is going to be coming in through these plates. So we actually want flow to be moving from this cold side to the hot aisle. So it's actually moving in the negative x direction. And that is actually the same for this row here. So for this row and this row, we can assign these together. Therefore, we can make that assignment using the box select tool for both of these. And we can say that the fluid flow is moving from right to left in the negative 0.3 meters per second direction. Okay. Now, that's only half of the servers. As you might have guessed, we've got to do the exact opposite for the other two rows. Okay. So we're going to now save this momentum source. We're going to create a new one. And we're going to basically do the same thing, exactly the same. Okay. Box selection tool from bottom right to top left using this selection feature. Orange or yellow selection box. Selecting the last two server racks. That is far left row and third from left row. Okay, these two. And they're going to be moving in the positive x direction with a magnitude of 0.3 meters per second. Okay, so this is the assignment, 0.3 meters per second in the UX direction. And once you've actually completed that step, we are there. Okay, we are Milestone 7 complete, rolling on to Milestone 8. Now, Milestone 8 is to actually define some probe points within the space. We're running out of time a little bit, so I'm going to skip over this. It's not essential to the setup, okay? So please can you all navigate to Milestone 9, okay? So Milestone 9 is simulation setup complete, okay? We've got to do nothing else to the setup apart from run a simulation, okay? And this is like the finale. This is where you actually send a job off to the servers, SimScale does its thing, sends you an email when the simulation is complete, and you can come back and check results. And to do this, we come down to this, this last red circle that says simulation runs, okay, the exciting bit. And we can press new simulation run. That's the little plus button just next to simulation runs. And it gives you a little bit of information. So before we start, it says, oh, okay, it's going to probably take 70 minutes compute. It's going to take 37.7 core hours to run. And by the way, what do you want to call it? And I'm going to call it run 1 because I'm completely unoriginal. And I can move down to the start button and I can press start. And this whole process of solving the simulation commences. The job gets sent off, it starts solving. And that actually concludes Milestone 9, okay? Sorry, Milestone 10. So if I can please encourage you all to then navigate to Milestone 10. And this you will find under simulation runs has actually got a simulation run that's already complete for you. Okay, so this is something that you can now come in and analyze the results for the thing that you've just set up. You've just spent an hour setting up the simulation. This is reaping the rewards. Okay, this is where we can actually come in and see what we actually get out of it. So I'm not going to go slowly here. I'm not going to show you every single line item here. The most important one for you is solution fields. So under run 1, so that's simulation runs, run 1, we've got a thing called solution fields. Now these are your 3-dimensional results. So please click on that. And it gives you a little option the option you want to select out of the two is the new beta interface. Okay, this is what we're working on at the moment. It's a beautiful user interface that hopefully showcases the best of SimScale, really. So we're going to click new beta interface, and we get brought into this this lovely viewer where we can actually start visualizing three-dimensional results. Now, what's quite interesting here is that we get a default view. Okay, so it does some sort of post-processing for you, although it might not be exactly what you want to see. So let me just zoom out a little bit so we haven't just got a big blue screen. And I'm going to rotate the geometry a little bit. Okay, so I want to rotate it into this kind of view. Okay. And what I want to do first, okay, is to change the direction of the normal orientation. So we've got a cutting plane in here, but we can't see it. So we're going to change the orientation. Now, next to orientation normal, there's this toggle button, and we can actually click that. Okay. So that means that we've actually seen this cutting plane that's on top. So this is what this cutting plane actually means. And what I'm going to do is I'm going to change what it's colored by. So what are we actually seeing in terms of results? We want to be looking at temperature. Okay, so I click this coloring section and change it from velocity magnitude to temperature, which, if yours is the same as mine, is about the second from the bottom. So what we actually see here is the color field representing temperature. So above the patches where cold air is coming in, it's cold. And on the other side, in the hot aisle, where warm air is actually moving from the servers into this hot aisle, it's warm, as we hoped. Now, I'm not going to spend too much time here because actually we're coming to the end of the hour, but I will just quickly show you two things. Firstly, I'm going to show you how to visualize the flow field or the flow direction onto this. And to do that, we can actually toggle what's called vectors. So this is a little toggle here next to, on the cutting plane, next to vectors. We're going to toggle that button. And you can see that something happens. A lot of little arrows appear. And this represents the direction of the flow. Now, when we're looking at a cutting plane, what's actually most useful to us is to understand what that flow is doing on this cutting plane. So instead of in 3 dimensions, we want to see it in 2 dimensions. And we can do that actually by navigating down at the bottom of the vectors section. So there's a little section here for the vectors, lots of information, lots of different options. But at the bottom, there's a project vectors onto planes option. I'm going to toggle that. Okay. And what I'm also going to do is I'm going to move up to coloring, and I'm going to change it from bivector to solid color. So now you'll notice actually that they've turned white. Now, white isn't the most visible color. So I'm going to, just next to that solid color option, I'm going to select it and press black. Now, in my opinion, this creates a very powerful visualization. So we can not only see the temperatures throughout this entire space, but also the direction of that flow. Okay. Now we can then go away and use this to understand what these results actually mean. We can really understand how flow is moving. For example, in this little area here, we've actually got flow moving through the server and then re-entering the cold aisle, which is completely not desired, also representative in the results field, because we've actually got this hot section. And in general, it's actually much hotter than it is on the Center 2 server racks. And we can use results like this to improve our design, our layout, and also what kind of setup we've got. So, for example, we could have doors on the aisles. We could also have complete enclosures over those aisles.
Darren, this is absolutely fantastic. Really good, thank you. Do you mind just showing a particle trace before we end as well, just to show people how to put a particle trace on?
Of course, Steve. What I try to avoid, of course, is doing too many clicks at once, but I can try and do that in just a few minutes. So The first thing to do, I think, for a particle trace would be to hide that cutting plane. So we no longer want to see it. We don't want to activate it. And also, I think what's handy here is we actually go to part color, and we change that from temperature to actually just a solid color. And we visualize this as just a box. So we can see this almost as it was when we were setting up the simulation. And what I want to do is I want to then add this particle trace by adding a new filter. So this new filter is available in this section under this big blue icon, Add Filter. And we can come down to particle trace, and it kind of changes the visualization a little bit when we click on this. So click particle trace, does a little bit of thinking. Now what we want to do is we want to select something to seed these particle traces off of, okay? And in most cases, what this is going to be is your inlet face. So I'm actually going to select this, this inlet, for example, here. And once I've selected that, we should start seeing a particle trace visualization. There we go. And this is a good way of finding out in 3 dimensions what your flow field is doing. So for example, flow is actually coming up from this, this underfloor area, is in part moving through the server, but also in part is going over the server and around the server, and that's maybe not quite desirable. Now I think what we also want to do here is change the color that we're visualizing. So velocity might not mean much to us. We can already see how the flow moves, but we want to see what the temperature is. So I'm going to come down to particle trace coloring and then change that to temperature. And here we get an understanding of what this temperature actually is. It would also be probably the right time to explain to you that we can change the unit in which we visualize. So we've got temperature here that's in degrees Kelvin, which I think for most of us isn't very natural. What we actually might want to do is degrees centigrade. So nothing's changed except the unit that we're viewing, and we can see that we're actually looking at a color range of 18 degrees Celsius up to about 48 degrees Celsius. But to make that perhaps more usable to us, we can change that to 50 degrees Celsius to give us a nice square number to visualize that one. And I think there you have it. We are complete milestone 10. In fact, we are beyond milestone 10. We're finished now. Okay. And what I definitely encourage everybody to do is, of course, take this simulation setup, see how you can modify it. You know, use it to your own advantage. Use this as a starting point for your simulations, and perhaps even reach out to us and to show us what you've accomplished with this workflow. That'd be great. Steve, is it okay if I hand back to you?
Yep, that's great. Thank you, Darren. That was fantastic. Thank you for that. I really enjoyed following along and seeing all of the different steps. I'm sure our attendees have as well. There was a few questions came in as we went through. I've fielded those questions and answered them privately. There was nothing that needed to be answered to the whole group. There was one question that asked how we estimated the actual momentum source velocity. So I just responded to say that that was as per the specification of the fans used in the racking. That is correct, isn't it, Darren?
Yes, actually, where I started was a flow rate. So I actually knew what the flow rate through the server was. That was predefined from the specification, and then I essentially back calculated the velocity.
Excellent. So thank you everyone for attending. If there's no final questions, we'll close it there because we're a few minutes over time. So thank you very much for attending. And as Darren said, we'd love to see the results that you've generated. And if you have an interest, please get back to us, contact me or Darren, or contact sales through the application itself. Thanks, bye.
Great, thanks very much. Cheers, everyone.